Let's start. Hello, everyone. I have to say that I'm quite impressed by the number of people who are interested in such a boring topic as disk partitioning is. But thank you for coming. Let me start with shortly introducing ourselves. My name is Petr Uzel. I work for SUSE, and one of my responsibilities is that I maintain the Util Linux package and parted package. If you know, I don't know if you know that the Util Linux package is the one which ships the fdisk-like utilities. So I'm basically the partitioner guy for SUSE, at least the user space part. So just to let you know what's my connection to this talk. And the guy standing next to me, it's Bueso, who worked on fdisk during this summer at the Google Summer of Code. So he's the one to blame if fdisk stops working for you when you update to new Util Linux package. Yeah, this is just an overview. We can skip this one. You might be wondering why we decided to dig into the partitioners code, because, well, yeah, there are a couple of packages or a couple of projects which take care of partitioning, which do the partitioning, and to give you some idea why we decided to work on fdisk and not any other partitioning tool, I would like to present you the short list of available partitioning tools and sum up their advantages and disadvantages. So the first one, it's GNU Parted. It's quite widely used package or project or software or whatever for partitioning, obviously. One of the advantages and big advantages and the reason why it's used so widely is that it supports basically anything which you can have on the drive which has something to do with partitions. For example, GPT, the legacy, MBR, AIX, GVH, and all those crazy abbreviations for partitioned labels, which I don't even know what they mean. But yeah, the thing is that it supports basically everything, and it presents nice unified API on top of the core functionality, which means, yes, it works the same for whatever you have on the disk. This could be considered an advantage, but also it comes with some disadvantages, which means that basically the support for almost everything makes it very inflexible. At SUSE, we have to deal with various types of problems which are almost impossible to fix in parted because of its, at least in my opinion, extreme inflexibility. So yeah, in 99% cases, it works perfectly, but in the rest it's almost impossible to fix. That's how I see that. Yeah, another advantage, that's the presence or existence of FlipParted, which is the shared library supposed to, for partitioning, obviously. And as I told you, it's very inflexible, so that's it. Then we have GPT fdisk, which has great support for GPT. More about GPT, Dave will tell you what GPT is good for if you don't know that. So yeah, it works perfectly for GPT, but it works only for GPT, so not that useful. And last, we have the fdisk family. This is actually what Dave will what we will talk about. Just to give you one idea about the mess we have, all these three utilities, fdisk, cfdisk, and sfdisk, are part of the same package. That's the Util Linux, but it doesn't share any code. So that somehow, it's a mess. And yeah, Dave, it's up to you now.
Thank you. So the fdisk family, as Petr said, it's part of the Util Linux package, and I've been hacking around programs and utilities in this package for some time, and in our to-do file, there is always fdisk, clean up fdisk, and it's been there. Nobody really wants to do it, and I don't blame him. So to further understand why, I don't know if you've ever seen the code, or at least the one that used to be there, but it is Smelly legacy code. It's been around, the fdisk itself is for around 20 years. And over the time, it's been subject to multiple hacks by different programmers with different ideas of what this utility should do, should be like, behave. So we have a ton of different coding styles, even stack jumping still, where we still had it till a few months ago. So all this is a result of code that's really glued together. And as you can imagine, it's difficult to understand. When you hack it, it is very error prone because of its complexity of reading the code. So that's mainly the reason why I chose to revive fdisk. So that's basically me during the summer. Very, very bad. So fdisk was stuck in the past. We only had DOS compatibility mode, no GPT support, except for recognizing a GPT disk. The legacy cylinder head sector addressing, and the user interface for fdisk itself is quite nasty. And as Petr said, the other tools, cfdisk and sfdisk, had their own implementations. There was no reusing code. So, what happens with all this? Hackers lose. I don't blame anybody for not wanting to add new code and extending functionality because it's difficult, tedious, and error-prone. And as a result, users lose as well. In the current state, fdisk could not compete with other disk partitioners, for example, parted. And healthy competition is good for everybody because the more competition, the better the code is, the better functionality, and the community grows. So, to fix all this mess, we need to update fdisk to modern 21st century disk standards. The short-term goals, which was the actual work I did during the summer, was to clean up and refactor current legacy code, create an internal API that abstracts the specifications and complexity of disk labels, and finally add GPT support. All this is towards the greater good, which are long-term goals, is to create an independent shared library, like libfdisk, kind of like libparted, what libparted is to GNU-parted. And with that new library, rewrite the other remaining tools, which is cfdisk and sfdisk. Since fdisk is quite visible, and it's been around for a long time, we obviously can't break backwards compatibility. In fact, the maintainer of the Util Linux package is very, very strong about this, and I, of course, agree. And the quality of the code that we're replacing it with has to be good quality. I don't ever want to have to do this again while I'm alive, so I hope that it sticks for at least the next few decades. So we're going to see, I'm going to talk a little bit about the new internal API, which is still internal. It's not a shared library yet. Some of the things I'm going to mention are things we want to, other things are things we have already. And we're also going to see about GPT support. So the new internal API is, an idea is to create an abstraction between the partitioners and what the partition tool implementation, like, for example, the user interfaces, and what the actual functionality of the disk partitioner should provide. We decided to use a driver-based model to deal with disk labels and handle the events through callbacks. For example, adding a partition, verifying integrity, getting the amount of free sectors, things like that. And this API can be seen first as a generic it can handle generic disk logic, like topology sectors and master boot record, and also a gateway to the internal specifics of each disk label. We have a central data structure that's our fdisk context, which is an opaque structure. We plan on adding version symbols to allow better flexibility. And perhaps the most important thing to explain is that it describes the disk. So through this structure, we can access everything from the disk, and internally we can access all the disk's operations through the disk labels. Here's a little overview that's a bit more clearer. We can see that up top, fdisk, cfdisk, sfdisk, any disk partitioning program will use this API to both do common disk utility things like initialization and device discovery through topology and geometry. And when we need to work with disk label specifics, we can see it as gateway. The API will handle the other part of the label specifics. For example, DAS, BSD, SGI, GPT, SUN, etc. And here we have the specifics that might be probing or adding, deleting partitions, etc. What benefits does having an API bring us? Well, we can unify concepts and specifications, yet without hiding the details of disk labels. It simplifies our work. It makes the code easier to read and modify. And this leads to detecting bugs easier and reduces the probability of introducing new ones. And as I mentioned, once complete, we intend to have a shared library. This internal API was the first thing I did during the summer. And once I had this finished, the next step was to implement GPT support. I'm proud to say that because of these changes in the API, adding a new disk label support was considerably easier. So I could just deal with the complexity of GPT and not the complexity of fdisk. So what is GPT? It's a standard for laying out a partition table on a disk developed by Intel in the late 90s. And the main idea was to overcome the limitations of the master boot record. Nowadays, it's part of the UEFI standard as well. Basically, when we describe the benefits of GPT, we're also talking about the problems of MBR. For example, GPT does not care anymore about logical or extended partitions. GPT can handle at least 128 named primary partitions. Since it uses 64-bit addressing through LBA, if we use a typical 512-byte sector size, we can get up to 9.4 ZBs in each partition. It has 32-bit checksums, CRCs, for data integrity, and it has redundancy through the data structures, which, of course, protects against disk failures. For example, MBR, only since it has a 32-bit addressing, it will only extend to 2 terabytes. There's no redundancy in the data structures, so disk corruption is a lot more serious. But there's no such thing as a free lunch. So the drawbacks could be seen as currently there's not all the operating systems support GPT, the same with the bootloaders. And we have strange non-standard schemes like the hybrid master boot record that, for example, is useful for systems that don't know about GPT, like Windows 7 or XP. XP, okay. So we have some weird things going on as well. So it was a well-known fact that fdisk didn't play well with GPT. In fact, when it recognized a GPT disk label, it said, please use GNU parted. So it's pushing users away. When the users decided to actually use fdisk with GPT, it could only use the protective MBR, which is the legacy DOS partitions. And finally, last month, we got GPT support merged in mainline fdisk. I would say full. It has all the necessary things, code to deal with GPT, but it's still in a very experimental phase. So use it at your own discretion.
I was just wondering, one random idea, whether we should patch part it to send the users back.
Yes, actually, that would be quite fair. Like, regain our users. So some details, like some things that are different from our implementation than you see in others of parted and GPT fdisk. First of all, we deal with both legacy and hybrid MBRs. When we write data, the in-memory data changes back to the disk. If we're using a if we're using a hybrid MBR, we actually don't write anything, because if we did, we'd be replacing it with a protective MBR, and that's immediately a problem. Every time we're modifying the disk's layout, like adding partitions, deleting them, we immediately verify the integrity through the checksums, not only when we write the data to disk. Petr here was recently trying the GPT support with larger logical sectors with 4Ks instead of the standard 512. We provide generous support for GUID partition types. When you're going to add a new partition, it defaults to Linux partition type, but you can change it, and there's a lot of options to add to. Okay, so this is a start. There's still plenty to do. One to do might be enhance fdisk's user interface. I like GDB style libreadline with automatic completion. Support more disk labels. I'm planning on, in the near future, as time allows, to implement Apple partition map. We also need AIX, and I'm sure there are plenty more. There's still cleanups to be done. We need to write proper documentation. For example, Parted has a very nice manual, which is not the same as the man page. It has an extra manual. And of course, test. The most important part. And thank you for coming.
Yeah, we ended up pretty fast, but we were hoping that there would be at least some questions. Yes. Yeah, there is one.
Okay. Well, I have one question which intrigued me from the beginning. How did you manage to rewrite the API so that it is general, but you didn't fall into the same trap as GNU parted, so it's flexible?
Yeah, that's what we thought about, and the idea is, yes, make like 2 layers in the API. First one, parted like, which handles everything. That's the 99.9% cases which work fine. But also, we want to write a thin API, which would be functions label specific. For example, I don't know, one idea which comes to my mind is a function bound to GPT, which would create a hybrid protective MBR. For example, this. I tried to solve this problem with Parted, and it was really impossible. It ended up in a horrible, horrible patch, which I hope nobody has seen so far, and I definitely don't want to push that upstream because it would make no sense. That's it. One of the problems Parted has, or the library, the libparted library, is that it doesn't use any version symbols in the API, which makes it really, really inflexible. And everything in Parted, it really works fine, but it's not extensible. Not at all. At least I can't do that, and I don't think anyone else can without rewriting it completely.
Just messing around with hard disks isn't something, well, someone can do unless they have a laboratory disk to work on. So I'm just curious, at what level are you with the release of fdisk? What other distributions have it included, at least your release? And at what point do you think, well, it seems like now it's in beta, but at what point do you think it would be release time?
Let's see. The first part of the project, which was the internal API, was part of the last release of Util Linux, which ships fdisk. There's a release cycle of this package every 6 months or 4, twice or 3 times a year, more or less. So we recently got the second part of, which is the GPT support in. So we'd have to wait like 3 more months, 2 more months for it to be available in the next version of Util Linux. There's a big message that it's still in beta stage. So in any case, since distributions are using a older version of Util Linux, like 1 or 2 versions behind, it actually won't reach end users till next year, more or less. So I'm calculating a formal, like it's stable enough, in another at least 5 months. Thank you. Mm-hmm.